Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, IIT-Jam, Jest and other exams related to physical science. Okay, so this is the lecture number 30th of mathematical physics, in which I'm going to discuss probability, guys, which is very important. You will get questions of probability in your examinations. Okay, so also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, so I'm going to start now, but meanwhile let me check whether I'm audible or not. Okay, important, you will get questions of yes, I'm audible, so I'm going to proceed further. Okay, guys. Okay, so probability. Okay, so first, what is probability? Probability is numerical measurement, numerical measurement, numerical measurement of numerical measurement of degree of numerical measurement of degree of certainty of the occurrence of an event. Okay, so this is probability is numerical measurement of degree of certainty. Okay, degree of certainty or certainty of the occurrence of an event. Okay, so that is probability. So numerical measurement of degree of certainty of the occurrence of an event. Okay, that will tell the probability, that is the certainty. Okay, degree of certainty of the occurrence of an event. Okay, or mathematically we can write as PA equal to, that is probability, it is number of favorable event, number of favorable event number of favorable ways. Okay, number of favorable ways upon total number of ways. Number of favorable ways upon total number of ways. Okay, that is the probability. Okay, now I'll write some definitions which are very important, okay, to understand probability. Okay, so like sample space, sample space. Okay, sample space, what is sample space? Sample space is set of all possible, all set of all possible outcome, set of all possible outcomes of an event, of an event. Okay, so sample space means set of all possible outcome of an event. Okay, so all possible outcomes of an event called sample space. Okay, next is next is trial. What is trial? Okay, these terms are very important to understand the probability. Okay, what is trial? Trial means performing a random experiment. Okay, performing performing a performing a Performing a random experiment. Performing a random experiment, that is called trial. Okay. Next is event. So what is event, guys? Event means outcome of the experiment. Okay. Outcome of the experiment. Okay. Outcome of the experiment. Okay, so these terms like a sample space means, in simple word, all possible outcomes. Okay, and trial means a random experiment. Okay, and event means outcome of the experiment. Okay, what is the result of the experiment or outcome of the experiment? Okay, so that is event. Now I will define event. There are different types of events. I'm going to explain by the chart. Okay, so first is equally likely. Okay, equally likely event. So what is equally likely event? Okay, equally likely. Equally likely. What is equally likely means no preference. Okay, no preference. No preference. Okay, so that means so for example, I'll explain by example. Example is, right, dice. If you throw the dice, okay, which are means so any number can come. Okay, any number can come. So there are 6 number in dice, right? So all the numbers are equally probable, right? So that so this type of event is called equally likely. Okay, so there is no preference. Okay, so if you are throwing dice, so all the 6 numbers are equally probable. Or if we are throwing the toss, if you are tossing the coin, so head and tail both are equally probable. Okay, equally likely. So this is equally likely event. Okay, next is independent. Independent. Independent event. So what is independent events? No influence on each other. Okay, that means no influence. No influence on each other. No influence on each other. Okay, that is independent event. Okay, no influence on each other. For example, example is tossing 2 coins. Okay, tossing 2 coins. If you are tossing 2 coins, they are not going to affect each other, right? So that is called independent events. Okay, so no influence on each other. Okay, so or if you are throwing 2 dice, right, so they will not affect each other, right? So that is called independent event. Next is mutually exclusive event. Okay, mutually exclusive. Mutually exclusive event. What is mutually exclusive event? It means happening of one event excludes the other. Okay, so that is happening of one event. Happening of one event excludes another. Okay, so this is happening of one event excludes another. Okay, so this is called mutually exclusive event. For example, if one event is happening, other will not happen. If other event, if second event is happening, first will not happen. Okay, that is called mutually exclusive events. This is very important chart, guys. You have to note down. Okay, next is condition for probability. Okay, so first of all, these terms you need to understand. Okay, like if I have written P A B. Okay, if I have written this P A B, what is it? So what does it mean? Okay, it means probability of an event A. Probability probability of an event A, probability of an event A, okay, when B has been, when B has been successfully completed. Okay, important thing. So PAB means probability of an event A, probability of event A when B has been successfully completed. Okay, so probability of an event A when B has been successfully completed. Okay, so this sign indicates this. Okay, now, okay, like given A and B, A and B are mutually exclusive. Okay, are mutually given A and B are mutually exclusive, A and B are mutually exclusive, so it means P A union B, probability of A union B is going to be equal to PA plus PB. Okay, next is so this is and second, given given A and B are not mutually exclusive, not mutually exclusive. Okay, given A and B are not mutually exclusive. Okay, if A and B are not mutually exclusive, then P probability of A union B is going to be, okay, PA plus PB minus P intersection PA intersection B. Okay, and third is for independent event. Okay, for independent, this is for mutually exclusive. Okay, and this is for not mutually exclusive. Okay, now next is for independent event. Okay, for independent event, for independent event, for independent event, if it's independent event, probability of A intersection C, A intersection B, A intersection B, if it is independent, then PA intersection B is going to be equal to, that is P PA into PB. Okay, probability of A into probability of B. Okay, right, and also you need to know this one, or P A intersection B is going to be P BA PBA into PA. Okay, or you can write P AB into PB. Okay, and here A and B are independent. Okay, A and B are A and B are independent. A and B are independent. Okay. So this you need to understand. Okay. So this means probability. This is important. Okay. Probability of an event A when B has been successfully completed. Okay. So now I'm going to explain Bayes theorem. Okay. That is Bayes theorem. Bayes theorem. Okay. Bayes theorem. It is Bayes theorem. Okay. Bayes theorem. So what Bayes theorem says, very important guys, we'll solve question. Okay. So this is P BK A is going to be equal to P BK P ABK upon sigma I P PBI into PBI into P PABI. Okay, this is very important formula. We'll solve question, then it will clear your doubt. Okay, so this is PBK PBA equal to PBK PABK upon sigma PBI and PABI, right? So this means the probability of happening B, right, when A is already happened, right, is probability of happening this B into probability of getting A when B is already done, right, and then sigma this. So I'll explain this by question, by solving question, right, then it will clear your doubt. So as of now, just know that this is the formula. Okay. Okay, this is the one. Okay, so I'm going to solve question, then it is going to clear your all doubt. Okay, so question is, a bag contains a bag contains a bag contains a bag contains two white and three red balls, two whites and three red balls and a bag. Okay, and bag second, bag 2 contains three white ball, three white and four red balls. Okay, four red balls. So bag A, first bag contains two white ball, three red ball. Okay, two white ball and three red balls, and second bag contains three white ball and four red balls. Okay, if the bag is if a bag is selected, if a bag is selected at random if bag is selected at random and a ball is drawn from it, and a ball is drawn from it if the ball is white, if the ball is white, then probability that then probability that it is from back one. Okay, so this is the question, guys. Question is, a bag contains two white balls. Okay, I'm going to make a figure. There are two bags. Okay, this is bag one and this is bag two. Okay, so this bag contains two white ball, and this bag contains three white ball. Okay, and first bag contains three red ball and second bag contains four red ball. Okay, this is the case, guys. So a bag contains two white ball, three red balls, and bag two contains three white ball and four red balls. Okay, if a bag is selected at random, so we have selected bag at random. Okay, a ball is drawn from it and then we have drawn the ball. So if the ball is white and we've got white balls, then the probability that it is from bag one. So we need to find out probability that this is from bag one. Okay, so I'll explain it. So we have a formula, right? So first we'll write B1. B1 is choosing bag one. Okay, probability B1 is choosing bag one. Choosing bag one. Okay, so because we have to draw the ball either from bag one or bag two, right? We have just selected at random. So B1 is bag one. Okay, guys. B1 is bag one, and B2 is choosing. B2 is choosing bag two. B2 is choosing bag two. Okay, and A is choosing white ball. Choosing white ball. Okay, A is choosing white ball. Okay, let's suppose. Okay, so now B1 is choosing bag one, B2 is choosing bag two, and A is the choosing white ball. Okay, so this we will say. Now we'll consider. Now we can get probability of choosing ball from bag one is going to be, because there are only two bag, right? And we are choosing random, right? Randomly. So probability of choosing bag one is going to be half. Similarly, probability of choosing bag two is going to be half, right? Total probability is 1, right? So now we'll use Bayes' theorem. Okay, so Bayes' theorem is very important theorem. Okay, Bayes' theorem is that we know, right? P, so we'll use here P B1 A. First I'll write this formula P BKA, which I have told you, which I have explained. P BA into probability of BK into probability of A from bag BK upon sigma I probability of BI probability of BI into probability of A BI, right? This one. Okay, probability of bk upon probability of this, and probability of bi upon probability of k, right? So this from here it is going to be, so we have to find probability that white ball is chosen from bag one, right? This we need to find. If ball is white, then probability that it is from bag one. Okay, so we'll find this one. P, this is probability that white ball chosen is from bag one. Okay, is from bag one. From bag one. Okay, probability that white ball chosen is from bag one. So that is going to be P B1 A, right? Because here A is the choosing white ball, right? P B1 A is going to be P B1, right? P B1 into P A B2, right? P A B1, right? Probability of choosing, probability of getting white ball from bag one, right? Upon, this is going to be P B1 plus P A B1. This is, you have written wrong, guys. So this is not plus, okay? P A B1, this is sigma, right? So plus P B2 into P B B2A. No, this is PAB2, PAB2, okay, PAB2. Okay, so now probability of choosing bag one is, we know. I'll write in next page. So this one, probability PB1 means this is probability of getting white ball, the probability that the white ball is chosen from bag one, okay, which we need to find. So probability of choosing bag B1 is 1 by 2. So this is going to be 1 by 2 into, this is probability of getting white ball from bag 1. So this is, we know here, right? Because here you can say bag 1, how many balls are there? 5. And getting white ball means total favorable number of event are 2. Favorable number event are 2 and total event are 5, right? So this is going to be 2 by 5. So probability of getting white ball from bag B1 is going to be 2 by 5. Very important, guys, understand that. Okay, this is probability of getting white ball from bag one, right? So in bag one there are 5 balls, total number of event 5, and the favorable number of event means white balls are, total number of white balls are 2, so 2 by 5 upon, this is probability of this one, this is same 1 by 2 plus 2 by 5 plus here probability of choosing bag 2 is 1 by 2, that we know, right? This one. Now probability of getting white ball from bag 2. So white ball from bag 2 means in bag 2 there are 7 balls and 3 white balls. So probability is going to be 3 by 7 because 3 white balls. So 3 by 7. 3 by 7. Very important step, guys. Okay. So now we'll solve it. If we solve it, so this value is going to be 2 by 10 upon, this is going to be 28 by 28 plus 30 by 40. Okay. So this value is going to be equal to If you solve it, so this value is going to be 14 upon 29. 14 upon 29. This is the answer, guys. Very important. Okay. So this is the answer. Very simple. So you need to understand this definition. Okay. So this means probability of choosing bag 1, probability of getting white ball from bag 1. Okay. And this is different. This is probability of getting white ball from bag 1. Okay. And this is probability that white ball is chosen from bag 1. Okay. So this is the very important formula, guys. Okay. I will solve one more question, then it will be more clearer. Okay. So Bayes theorem is very important, guys. Bayes theorem. Okay. Next question is and from here also one more question. From here we can also get PB2A, right? This also I'm going to tell you PB2A, right? PB2A, PB2A. It means probability. It means probability that white ball is chosen from bag 2. Probability that white ball is chosen from bag 2. Okay. This is going to be, right? We can write this formula again. P2, PB2 and PAB2, right? Upon PB2 into PAB2 and plus PB1 into PAB1, right? This we can write, or we can reverse the order. We can write first this, then this. Okay. So this one, right? So this is going to be like probability of getting probability of choosing bag 2 is 1 by 2, and probability of choosing white ball from bag 2 is, we know, that is 3 by 7, right? Upon this is, this we know, right? This we know, 1 by 2 into 3 by 7 plus this one, probability of choosing bag 1 by 2, probability of getting white ball from bag 1 is going to be 2 by 5, right? So we'll solve it, and this value is going to be 15 upon 29. Okay. This is the answer, or we can directly find out as well, because we've got probability that white ball is chosen, probability that white ball chosen is from bag 1 is this. So white ball is chosen from bag 2 is going to be, directly we can write 1 minus this value, 14 upon 29, 14 upon 19. My apologies, 29, guys. Okay. Mistake, 29. And this value is 29, right? So this is going to be 14 minus 29. This value is going to be 15 upon 29. Okay, this is answer. But I have explained this in this way, because you will be able to, then you can understand, you will be able to understand how we have used this formula, Bayes formula. Okay. So to make it more clear to you, I have explained it. Okay. Next question is, next question is next question is a bag contains a box contains a box contains A box contains, you need to know how to use this Bayes theorem, okay, very important. So many questions you can easily solve, and these questions are asked in part C section of NET examination, guys. So very important formula, the Bayes theorem is, okay. A box contains nine fair coins, and one double-headed coin. One very important question, guys. One double-headed, one double-headed, one double-headed coin. Okay. One coin is chosen. One coin is chosen. One coin is chosen randomly. One coin is chosen randomly from the box. One coin is chosen randomly from the box. The coin is tossed 3 times. The coin is tossed 3 times, and we get heads all the time. Heads all the time. Heads all the times. Probability that chosen coin is double-headed. Double-headed. Okay. So this is the question, guys. I'll read it for you. Very good question. We'll use Bayes theorem here. Okay. A box contains 9 fair coins. Okay. 9 fair coins and one double-headed coins. Means in a box there are 10 coins. Out of 10, 9 are fair coins. Means in which they have head and tail. Okay. And one double-headed coin. So one coin has both side head. Okay. Double-headed coin. One coin is chosen randomly. So we have chosen one coin randomly from the box. Okay. Then the coin is tossed 3 times. So we have tossed coin 3 times. We get head all the time, and we have got head all the times. Okay. Probability that chosen coin is double-headed. Now we need to find out probability that chosen with the coin which we have chosen, that probability is getting that double-headed coin is, that probability we need to find. Okay. So I'll explain. So I'm going to use Bayes theorem here, and how I'm going to use it, that I'll explain. Okay. So first we'll say A is getting, from here A is getting 3 heads. 3 heads. Okay. Getting A is getting 3 heads in 3 toss. So this is the value of A. A is getting heads in 3 toss. Okay. And B1 is a double-headed coin. Okay. Double-headed coin, and B2 is fair coin. Okay. B2 is fair coin. Okay. So A is getting 3 heads in 3 toss. B1 is double-headed coin, and B2 is fair coin. Now we'll use Bayes theorem. So that is going to be, now we need to find probability that chosen coin is double-headed. Okay. So we have to find P. This is B1, right? PB1, because double-headed we need to find PB1A is going to be PB1 into PAB1, right, upon P B1 P A B1 plus P B2 into P A B2. Okay, so this is one. This probability that chosen coin is double headed. Okay, this is the probability that chosen coin is double headed, right? And this is probability of choosing double headed coin. Okay, and this is the probability of getting head from fair coin, sorry, from double headed coin. This is probability of getting uh, head, the same thing, probability of this one, probability of getting double headed coin. This is probability of same thing, probability of getting this one, probability of getting three heads. Okay, probability of getting three heads from heads, which is from double headed coin. And this is probability of getting uh, fair coin. Okay, and this is probability of getting head from B2, that is from fair coin. Okay, so we can easily find it. So we know, so I'll write here, from here PB1 is going to be probability of getting double headed coin. So it is going to be 1 by 10, because there are total coin 10 and double headed coin is 1 by 10. Okay, similarly probability of getting fair coin is going to be 9 by 10, because there are 9 fair coins and total coin are 10 including double headed. Yeah, this we know, simple. Now this is very important, probability of PAB1. Okay, so this is probability of getting heads from double headed coin. Okay, so this is going to be 1, because we have only one coin double headed. So probability of getting head from double headed coin is 1. This is very important, guys, this point, probability of uh, getting head from fair coin. Okay, so fair coin it is going to be, see, so toss is, the coin is tossed 3 times, right? 3 times means for one time probability of getting head from a fair coin is going to be 1 by 2, 1 by 2, because it's tossed 3 times. This 1 by 2, this is 1 by 8. This is very important, guys. PAB2, right? It means probability of getting head from fair coin. So probably getting head is 1 by 2 for fair coin, right? But it is tossed 3 times, because fair coin means there are either you will get head or tail. Getting head is 1 by 2 probability, and getting tail is 1 by 2. So it is, because it is tossed 3 times, so 1 by 2 into 1 by 2 into 1 by 2, 1 by 2, right? Now we'll directly put the value. Now we are going to put the value directly, right? So this is going to be PB1 is 1 by 10 into PAB2. AB1, this is 9 by 10 upon uh, this is 1 by 10 into 9 by 10 plus this is okay, this one 9 by 10, right? And this is, my apology, this is 1 by 10 into 1, because PAB1 is probability of getting head from double headed coin is 1. Okay, PAB1. So this is 1 by 10, 1 by 10 into 1, 1 by 10 into 1 plus this is going to be, this PB2 is 9 by 10, right, into 1 by 8 PB2, right? So you will solve it. So this value is going to be this. This is going 10 by 10. This will get cancelled. This is going to be 1 upon 1 plus 9 by 8 is remaining, because this will take common. Okay, and this value is going to be 18 by 17. Very important question, guys. Okay, 18 by 17. Okay, so this is how we use the Bayes theorem. Okay, next question, guys. Next question is this one. A very good question. This also. Okay. Question is the probability that A and B will die. Probability that A and B will die within a year. Within a year are P and Q respectively. Okay. So probability that A and B will die within a year are P and Q. Okay. So probability of dying A is P. Probability of dying B is Q. Then probability that one of them alive at the end of the year, one of them is alive at the end of the year, is. Okay. Options are option A, P plus Q, option B, P plus Q minus 2PQ, option C is P plus Q minus PQ, and option D is P plus Q plus PQ. Okay, these are the options, guys. So we can easily solve it. So we can write this probability of A B bar plus B A bar. Okay, simple. So this is probability of getting died. Okay, probability of this is A is this is probability of getting died, and this is probability of getting alive. Similarly, probability of getting died and probability of getting alive. Okay, so now so this is means this is okay, this is either or case, right? So here PAB bar means probability of A will die and B will alive. So because we need to find probability that one of them alive. Okay, one of them is alive. Okay, either one of them is alive. So this means this is PAB bar means probability of A being alive, A being died, and B being alive. Okay, so probability of dying A is okay. So this is going to be 1 minus B, because probability of this is right. So this is A, probability of A dying, right? So this is A bar and B bar, right? So A is indicating that this will alive. Okay, this is alive. So probability of A will be alive is 1 and B bar is dying. Okay, so this is going to be 1 minus P into Q plus 1 minus Q into P. Okay, so this is because either this means either this can happen or this can happen, means we use add in probability, right? So this is the probability of A being alive. Okay, this is the probability of B being died. Okay, similarly this is the probability of B being alive, and this is the probability of B being died. Okay, so A bar is showing that probability of dying, and A is showing, bar is showing probability of dying, and without bar is showing probability of alive. So A, we know the probability of dying, A bar we know, right? That is P. So A is going to be alive, that is 1 minus P into Q. And so if you solve it, so this value is going to be P. I will solve this in another method as well, right? Okay, so P minus PQ plus P minus PQ, and this value is going to be P. This is Q. P plus Q minus 2Q. So this is PAB. B is dying. Okay, bar showing the dying probability. Okay, so here A means probability of A being alive. Probability of A being died is P. So being alive is 1 minus P. Right? B bar is showing probability of B dying. Probability of B dying is Q. Right? Similarly here B is showing probability of B being alive. Right? B being alive means 1 minus Q, because B being died, B bar is Q, right? And A bar is probability of A being died, that is Q, that is P, right? This one, very simple. Next is so second method. Second method is this one, simple. So we need to find out probability either one or two will die, alive, right? So we need to find out this one, probability that one of them is alive. Okay, so any one of them alive. So this is going to be 1 minus both dies minus both alive. Okay, this you need to understand. Okay, so this is both dies and both alive. Okay, so we have to find either one of them is alive. Okay, so it means how we can get by this formula as well. 1 minus both died, probability of both dying, minus probability of both alive. Okay, if you minus these from 1, we will get probability of any one being alive. Okay, so this means 1 minus both dies means PQ, right? Because probability of dying A and B is P and Q, and minus both alive means 1 minus P into 1 minus Q, right? Very simple question. 1 minus Q. So this is going to be 1 minus PQ minus this is going to be 1 minus P minus PQ minus Q. Okay, so we'll solve it. 1 is going to be 1 minus PQ minus 1 plus P minus PQ plus Q. Okay, so this value is going to be P plus Q minus 2PQ. This will get cancelled, and this is answer. Okay, so this is the another method. Okay, so any of one being alive, so we have a formula that is 1 minus both dies minus both alive. Okay, this is very simple method, the first one. Okay, next question is, it's a good question, guys. Question is, it is asked in CSIR net June 2019. I have already explained in June 2019 PYQ series, guys. Okay, 2019 question. This is June. So question is simple. I'm just writing it. Okay. So this one, very simple question. Okay, so these are three diodes. Okay, D, D, and D. Okay, and this is diode D. So we need to find probability that current will flow. Okay, probability that current will flow. Okay, and we have been given D. Diode is the probability of diode being insulator is given. Insulator. I have explained it in detail in my June 2019 PYQ series. Okay, I have completed. I have solved that complete paper. You can check that series. Okay, so insulator is P. So for diode being insulator is P. Probability of diode being insulator is P, and probability of diode being conductor. Diode being conductor. Diode being conductor is Q. Okay. My apologies. 1 minus P. Okay. So this is what given. 1 minus P. Okay. 1 minus P. Well. So now so we know, guys, for this circuit to be conducting, right, the probability that the current will flow in this circuit, this should be conducting, and any one of them should be conducting. Okay, any one of them. If any one of them will be conducting, then the current will flow. Okay, if all three are, that is also good. But if all are insulated, if all will work as insulated, then it is not going to current is not going to flow. Okay, so for that we can write, first we'll find P1. Okay, that is probability that current will probability that any one of these three is conductor. Okay, so any one of these three should be conductor, and this must be conductor, then the current will flow. Okay, so P1 we are going to get, that is probability that any one of these three diodes being conductor. Okay, so this is going to be, we know that is going to be 1 minus all being insulator. This is formula, insulator. Okay, so probability that any one one out of these three diode I'm talking about, so any one of the diode is conductor, is there's a formula. This is 1 minus all the diode are insulator. Okay, very important. So P1 is going to be 1 minus all diode are conductor, means the insulator, right? So if this is insulator, this probability of this diode being insulator is P. So this is going to be all three diodes are insulator, means probability, right? P into P into P, right? So this P1 value is going to be 1 minus PQ. Okay, so now we'll write probability that current will flow in the circuit, means this value, that either this P1, right? P1 into probability of this diode being conductor, right? Then current will flow. So this we know, this is 1 minus P. Probability of diode being conductor is 1 minus P. So this is going to be this one. This is 1 minus P cube. 1 minus P1 is 1 minus P cube, right? 1 minus P cube into 1 minus P. Okay, so this is the answer, guys. Okay, so this is the probability that the current will flow here. Okay, very good question. Okay, guys. Okay, guys. Well, so guys, I'm going to stop here, and so next part we'll do in next class. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys, thank you so much. Bye now.